In today's lesson, we'll be learning how to determine the solution or point of intersection to a linear system using the process of elimination. In our first step, we want to stack equation 1 on top of equation 2 in standard form, and like terms need to be aligned. Our red equation is already in standard form. The x term and y term are on the left of the equal sign, and the constant is on the right. Our blue equation is also in standard form. The x and y terms are on the left of the equal sign, and the constant is on the right. We can also see that all of the x terms are lined up, all of the y terms are lined up, and all of the constants are lined up. Let's say we want to eliminate our x terms. However, we have a little bit of an issue. The coefficients are not the same. We want them to be the same. First, let's list out the multiples of 2. The multiples of 2 are 2, 4, 6, 8, and we can keep going on and on. Next, we want to list out the multiples of 3. The multiples of 3 are 3, 6, 9, 12, and that keeps going on and on. The lowest common multiple of 2 and 3 happens to be 6. I want you to take a look at the red equation. 2 times 3 gives us 6, but if I multiply this term by 3, I have to multiply every other term in that equation by 3. If I multiply that entire equation by 3, this becomes 6x plus 15y is equal to 54. We're going to repeat the exact same process with the blue equation. So 3 times 2 gives us the lowest common multiple of 6, but if I multiply that term by 2, I have to multiply every other term in that equation by 2. If I multiply that entire equation by 2, that becomes 6x minus 4y and 16. At this point, we can either add or subtract these equations to eliminate a variable. I'm going to subtract these equations. Let's copy our red equation right over here. Afterwards, let's copy our blue equation right over here. If I do 6x subtract 6x, that just becomes 0x, which means it cancels out and it gets eliminated. Next, I'm going to go positive 15y subtract negative 4y. Because we have two negative signs here, that just becomes a positive. So that becomes positive 15y plus 4y, which becomes 19y. And over here we have 54 subtract 16, which becomes 38. To isolate y, we just have to divide both sides of the equation by 19. These 19s cancel out, and y is equal to 2. At this point, you can take your y value and substitute it into any of the original equations and solve for your x value, which would eventually get you your solution or point of intersection to this linear system.